Today we go into our last chapter, chapter 8. It's a big chapter, but I try to point out the important point, which is important for your final exam. Okay. So we will do, we look at quality management, right? Quality management. Then there will be two parts. Today we look at a little bit on the how they manage quality in the factory or in the production floor. Then tomorrow, we will look at the graph, how you analyze graph, what is happening when you apply Six Sigma, how you know that your process is in control or out of control. Okay. Okay. So textbook quality is a level of excellence or degree of excellence. But again, in this module, when we talk about product development or project planning, we always focus on how our customer look at what is a customer requirement. So quality from the customer perspective, there are two. One is fitness for use, which is whether the product's able to do what is expected, right? So fitness for use. Another one is the quality. It's the quality that you put inside the services, right? So for example, the two cars on the screen here, although they are both are in white color, but both have four wheels. However, they are targeting for different segment of market. Okay, so fitness for use, both, yes, is automotive, but the one at the top and the one at the below, the fitness of use is a bit different, depending on the market segment, right? So on the top one, maybe the customers need to be have more demand if you use the above car, right? More demanding, and the quality also they use a better material for the car compared to the one at the below. Okay, and because of the material they use and also the quality of the products, they're able to sell that product at a certain range. So these two, they have a very specific market segment, which these customers will purchase this kind of product and will not go here. And this kind of customers will not buy this kind of products. They have a very specific market segment. Okay. So these are the dimension that you're focusing on. This one you read lah. A lot of parameter when you go into the production floor as a R&D department, as a production engineer, so or the project manager. These are all the parameters that you use to measure. So one of it you're already familiar is the reliability, and so on. Okay. So there are two. One, this one. This slide is for manufactured products. We just have all these parameters. These manufacturing products. And this slide is for services. One is for manufactured product, one is for services. Both have a different definition of their when you want to measure them. For this module, we don't go very deep into services. We go into manufacturing process. Okay. Of course, there are equation for the services measurement, but we don't. In our class, I don't into that. Okay. Okay. Now, from the producer perspective, just now we look at customer perspective. Now we look at producer perspective, means you are the manufacturer, you are the producer of that product, or you're producer of that services, right? So we are looking at quality of conformance. Quality of conformance, what I mean by conformance? It means the products or services, they are produced according to the design specification. So previously we studied about the flow of the design, the design chart. So conformance here, make sure the products meet all the design specification. Okay. So example is the tires, quality of conformance tires. So how you know the tires meeting the conformance? New tires, if they do not meet the specification, they will wobble, means it's not stable on the road. Okay, even though it looks new, but if the material or the inside there's no the density or the design is not wellly distributed, the CG point and all this, then when you put inside the automotive, it will wobble. It will not be stable, right? So this is a conformance. So again, hotel rooms in the terms of quality of conformance. This is products. This is services. So this is product, this is services. So for services, for example, hotel, in terms of quality of conformance, it's all the things that you feel like a service. For example, so, front desk services on time. You say 8 o'clock, okay, 8 o'clock, check out. 12 o'clock, you will really check out 12 o'clock and so on. Then breakfast, swimming pool, all these things. Okay. Okay. So this is one of the chart from the meaning of quality just now. So you have two parts. One is producer angle and consumer angle. So producer angle, just now we touched on about the quality of conformance. Then consumer is quality of design. Okay. Then the input is this one is production. Then fitness for consumer use. Okay. So again, no matter you are from the producer perspective, you still go back to, you still join with the customer perspective. Okay, so meaning of quality, usually you still look at the customer requirement at the end. Okay, the rest you read. Okay, now when we look at quality management system, there are few famous people, and for this module, we will look at a few approach or a few methods later. When you calculate something, the name keep popping up. So they are 7 or 6, I can't remember. So the first one is Walter Stewart. This one is quite famous. We will keep seeing this one, Deming, D-M-I-N-G, Deming. So Deming is a guru for quality or the QS system. Joran, Joseph M. Joran, also another method. We will also learn his method later on. Okay, so these two is the most famous one. Of course, between these two, Deming is the oldest one. You can say Deming is the guru of guru. Okay, I mean his approach or his way is quite popular among the quality management system. Okay, so these are all the other things. V. Philip Cosby and Kairu Ishikawa. This is Japanese. Okay, later we'll also look at this one. But in your assessment, I won't ask you this. But we will look at the analysis later. Okay, so for this guy called Deming, Deming have a famous 14-point philosophy of 14 points of quality achievement. So this 14, there's another slide. So 1 to 7 is what Deming philosophy. Okay, so this slide is important if your final exam asks you about what is elaborate on Deming philosophy or 14 philosophy. Maybe you name 3 or 4 philosophy out of 14. So I don't expect you to remember all. If this kind of question come out lah. So at least you know where is the information. All this. Okay, so these are the 4 stage, or if you do internship, you are in the QA department. So dimming wheel is very famous for QA system or quality control system. You have a PDSA, plan, do, study, or check and act. If this cycle is very important when you study about the quality management. Okay, this circle is introduced by Deming. Deming have 14 philosophy just now, which is the first, the famous one, philosophy. Second one is this wheel, 4 wheels. Is the foundation of the current QA system that you use in the manufacturing flow. Okay. Okay. So we start to look at introduce you a few tools that we'll be using for analysis for qualities. We have 7 tools, 7 tools, and we will pick 1 or 2 as your final exam question. Okay. So what are the 7? Process flow chart. This is the first one. So process flow chart, you will look something like this. Is oversimplified. So you have step 1 and then the process. So process was using different symbol, but then you draw the process from step 1 until step 3, how the process flow. Okay, so this is a process flow chart. Nowadays, all the software can plot this chart for you already. Okay, even can detect where is the error or what are the area of improvement for you. Nowadays, the software very advanced already. So first, process flow chart. What is the characteristic, or what is the, if you summarize all the textbook explanation, what is the process flow benefit, or what is a flow chart about? It will give you a clear picture, where I highlight on the screen here. It gives you a clear picture on the process, how the operation works. Okay. Then it tells you the relationship between department 1, department 2, or station 1, station 2, station 3. Okay. Yeah. So the first one is the process flow chart. We talked to you about process. Again, we are now in the quality management, means how you measure quality. You will measure quality at the final products. Let's say you already manufacture one product at the end of the production flow. So you found out that this product actually got some defect. Then you need to check back at what process got problem, right? So this process flow chart, you can pull out the first tools to see, okay, which process actually happen. For example, you are making a cup, a cup. So you discover that there is a crack, micro crack here at the final products. So the first tools that you use to check is there any problem with the process is to pull up process flow chart. You check what process that deal with this component. You pull which step 1 go where, then you go check which station doing with this one. Then you go and deal with the station. Okay, this is the idea of process flow chart. Second one, this one is also very famous in the quality, in the brainstorming or cost identification, or means the reason of some defect in your products. It's called cause and effect diagram. Cause and effect diagram, or it look like fishbone. Right? Look like fishbone. So it also called fishbone diagram. Okay. Second tool is called cause and effect diagram or fishbone diagram. It will tell you that what is the reason of the defect, quality problems. Cause and effect, very direct. The name means you find the cause of that defect. Okay. Then the next one is check sheet. Check sheet is a sheet for you to tick. Right. items, the parameter here, O, is it O? Tick. Temperature, is this temperature correct or not? Tick, and so on. This is a simplified check. So this one is to further detail. Let's say the glass handle here got one defect. So you go and check, is this the process correct or not? Is this the temperature correct or not? And so on. Okay. When you need to use or when you pull out these tools is during brainstorming. You call all the teams together and then discuss what actually happened to that particular problems. Okay, so this is a fishbone diagram or cause and effect diagram. The purpose is to identify the cause of that problems. Okay. Next one is this is another more detailed fishbone diagram, all right, or cause and effect diagram. For example, if you use apply Six Sigma approach by using cause and this fishbone diagram or cause and effect diagram. So this is a case study in a hospital to reduce delay in a patient bed turnaround time. Means there is not enough bed for the patient. So they did a brainstorming session to find out the cause. What actually the cause? What caused the bed turnaround problems? So how they built this flow chart or this chart? First, they name the problems at the head. The head is the problems. So they always put the problems or the project objective here. In this case, they put bed turnaround time here, the effect. This is the cause and effect. This is effect, right? Okay, we're going to dissect one by one. So at the end of the analysis, in this case, they found out that the main problem is here, the BTS, bed tracking system have some issues where there's an error when the nurse register the patient. Okay, this is just a hypothetical or there's an example only. This is what you want to, this is what happening actually, the problems. What you see, for example, the bed turnaround time is too slow. What actually delaying the bed? When the patient come in, they cannot find bed and so on. What actually causing the bed turnaround time so difficult or so long? So then this is the body, the possible reason that caused these problems. Okay. So in this case so we go step by step. So first you draw the effect box that you need to do correction on the far left or the fish head, the fish head. Then you draw the main bone. Main bone consists of the arrow from the tail to the head, and then all the arrow were pointing towards the body of the fish. So this depend on the brainstorming team, or maybe you can say as a department head. So each department have their own, come up with their own idea or own perspective. So maybe finance it as this way, manufacturing floor have this idea, R&D is this one, right? So they give you like this lah. Okay, so the center line, they are the major possible problems of the cost. So they draw the fish head first, then they draw the body, they draw the small arrow pointing to the body, and then this is the main department or the main region for that cost. Okay, then they elaborate this one. So this measurement department, they will come out with the reason, more detailed reason why the bed turnaround is so slow. So for example, measurement team, he say, oh, got the BTS, the bed turnaround system, got problems. Then machine also mentioned this one, and the rest are this one. One department also mentioned BTS. So from this fishbone diagram, you keep seeing BTS, BTS, BTS. So you as a team leader, you should focus on BTS, for example, lah, in this case, the reason that keep repeating inside the fish body. You focus on that one first. Okay. Okay. Sometimes in your team or in your company, they will, if especially when you work in a Japanese company, this is very common tools that you use. They will have brainstorming. So when they start brainstorming, they will draw this diagram. Then they will put in the reason, the input from the team. Okay. So, okay. Okay, next we will, from the fish bone, for example, we will build a table. There's a scientific way doing it. I won't test you on this, all right? But at least you should know there's a way of doing fishbone diagram. Okay, so in this case, you draw a table and you can use Excel and so on. So what you do on the left-hand side is the reason or input from all the department. For example, BTS, beds, time of day, and so on. Okay, so this is called cause and effect matrix table. Okay, so you put in all the things. So what is a component? First is you have y-axis variable, which is on the top. So you have 1, 2, 3, 4, 5, 6, the variables. You decide by the team also. You find out what is the main reason of this one. So how you find the main reason of this one? You look back at the fishbone diagram. It's all the orange color things. So you have all the key output variable. And then you have X, you have Y and X variable. Then have you learned about house of quality? No. No. Okay. Okay, never mind. It will be similar like house of quality. So then you will rank based on the importance to customers. So once you do, you input the customer rank, you label 1, 2, 3, 4, 5, and you find the relationship, you put in the weight here. Okay. Then you calculate the value lah. You calculate the value and you arrange them. Of course, this one I won't test you in your final exam, but at least you know there is a way of calculating the cause and effect. There's a tool called cause and effect, and there's a matrix diagram for you to and do analysis. Okay, next one is checklist. Checklist is quite standard. Means you go and check the components. For example, this one you tick, 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 tick. The next steps after you have checklist is to help you to build histogram. You know what is histogram, right? No. You know what is histogram? Histogram is something look like this is the histogram. Okay. So the rest you read. Okay. So you will build from the checklist, you will build this Pareto analysis. So you build this diagram and histogram. There's a two different, although they are both a bar chart, but the axis is a bit different. So Pareto analysis is more on the percentage and the problems. For example, this one is more on percentage versus the reason that contribute to the problems. Okay, Pareto is more on percentage. Histogram is more on frequency, like you count 1, 2, 3, 4, 5, and so on. So this is a frequency. Y-axis is frequency. The x-axis remain the same. The reason. Okay. So the background of Pareto analysis is based on Joran. Just now there are a few group names there. So it's based on Joran findings. that is to identify the causes of poor qualities. So Piratos is for finding the cause of poor qualities. This one is directly you can get from the production floor. You ask the operator help you to tick, or you just reject you keep counting the reject component. Then you can build this Pirato analysis. Okay. Okay, this one you read lah. Pareto analysis, because it's percentage. So from this graph alone, you know that reason A, the cause A, is the one that contribute the most among the production products. Means you need to focus on process A to solve that problems, to solve that defect problems. Okay, so A, B, C, D, E, F is all the causes that contribute to that end product. But from Pareto analysis, you focus on the highest one first. Okay. Okay. For example, from the bed problem just now, there is a department in the hospital. They come up with this table. So they have problems A to Z times of defect. They count lah, how many numbers of defect. For example, staff communication, how many times happen, staff miscommunication, and so on. Then you have a total of 130. How to calculate percentage? For example, how you get 64%? You get 83 divided by 130, the total case you have. Okay, then you get a percentage. Yeah. So once you build this one, you know that Pareto is percentage versus case. So you can convert this table with the percentage versus the problem here. You can build a Pareto diagram. Okay, something like that. Okay, now because this is too simple, I won't ask you in final exam. This is too simple already. Okay, if you're taking certificate, yes, this one will come up. Because you are taking degree program, this is too level for you guys. Too low level. Okay, so this is the thing lah. Another one, another tools, you have 7 tools. So these are the tools. Scattered diagram is, I think you're very familiar. If you do lab report, you have this, or you do FIP, most of the time you see this dot here. Okay, then you find a pattern for this one. This one, statistical process control chart, this one will come out in your final exam. I will ask you this diagram. Because this have a lots of formula, lots of steps to do. So this one, we can monitor whether you understand the quality tools or not. Okay, so this is statistical process control chart, which is also very applicable in your work later if you want to monitor any defect in the process. Okay, so later we'll go step by step how to do this one, maybe tomorrow. Okay, today just give you some introduction, what are the tools or some steps, like what you should do about that one. Okay. Okay, static diagram is like, for example, how you build this scatter diagram, you just take sample and then measure, take sample, measure. Then you plot a y versus x graph. This is quite direct. Okay, direct. Okay. Next, we talk about the TQM and QMS. TQM. If you go to work, TQM is a very popular word in the factory floor or any manufacturing plant. TQM is total quality management. Total quality management. So you focus on all these things. Right? We focus on customers, continuous improvement, quality improvement, accurate evaluation, and involve all the employees. So this is an important diagram. If the question asks you section A, what is TQM? Okay. So this one you read lah. This diagram summarize all the explanation. QMS is quality management system. It's a system to monitor the outcome of your products that meet customer requirement. Okay. So again, Deming's 14 qualities is just now you saw the table. Now it's more on the it's the same lah. It's the same. This one is more on the wording that you see. This is so Deming, they take Deming's 14 points, they summarize it into 8 points. It become the basic of TQM. So basically, they take Deming ideas, they summarize it, they squeeze it, become 14, become 8. The 8th one is the basic principle of TQM, total quality management. Okay. Quality circle is all this, the one that you see on the screen here. So what is quality circle? Quality circle here is it refer to the group of the team, or it means team, right? A group of workers and supervisor that form in the same area to address means to solve the quality problem. So it's an address. So this circle summarize a few pages of textbook. So what does the quality circle means? You consist of 8 to 10 members organization, then you give trainings to solve on the data collection, to solve problems. Then you identify problems, you come up with a brainstorming, you use the fishbone diagram, or you pull out all the data, the 7 tools that we covered just now, to find the causes of the problems. You analysis just now, analysis later we will do the graph, the data, whether the process is in control or out control. Then you give the solution. What station that you should focus on, what process you should focus on, then you fix it. Okay, then you continue to monitoring. So it's a circle, it's a process that you want. But in the quality terms, quality circle, it means workers or team. Working team. So the rest you read. The rest you read. Okay, now we go into Six Sigma. Six Sigma is a very popular certification program. If you have Six Sigma, then most of the time you will become quality manager, or you are the one who design process or monitor the process of the whole factory floor. Okay, because Six Sigma, if you look at the diagram, the sigma here is actually a statistical symbol, right? Sigma. So I'm not sure your statistics teacher or lecturer got teach you or not. Statistics, even in fact in our previous class when we learned about the probability, I show you one of the Six Sigma diagram, or sigma normal distribution, we call it diagram. So there is 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, and so on. So there's an equation to calculate sigma, right? So that one is important. So study that one for your test too. Study that one for your test too. But in this case, chapter 8, we go up to 6 sigma. The range is higher. Okay, the range is higher, and means if you have this one is negative side, negative, this one positive side. So if you cover 6 sigma, what does it mean? It means the error that in your process is very, very low, means higher precision monitoring. Because you imagine up to 6 sigma, you do 1 6 sigma, you already cover like maybe a few percentage of that probability already. You pull the graph until 6 sigma, means if you are doing very precision manufacturing, means sticky plus minus 0.001 reject like that. Okay. So the rest you read. History, you have to know if you want to work in Motorola, This is a very famous system in Motorola company. They are the one who introduced this system. Okay, Motorola. Also, if you want to work after you graduate, let me know. I have contact there. Okay, if you want to work, and I'm seeing good prospect also. Motorola, they are good in their telco, radio, all this. Yes. So you need, I mean, the product itself is actually you need in daily lives also. So if you need that radio communication in daily life, it also means there's a job security for you. Of course, you have to do your job. Okay. Most of my friends who work in Motorola, they is first job until today. So Motorola actually treat them quite well. And you really like engineering. Huh? Sorry? This one, Motorola, they have a lot. Because I'm from Penang, so there's one plant in Penang. Okay. Okay. Now, the purpose of Six Sigma is to improve the qualities, the process. Okay, the process. So the rest you read, the rest you read. And Six Sigma, the process, they go into the ultimate goal is to near zero defect goal, near zero defect in their process. Out of 1 million, maybe maybe nowadays when you apply Six Sigma, it can be billion, maybe one defect out of 1 billion piece. Because it pull it stretch the graph up to the end of the graph already. Okay, so maybe for 1 sigma, maybe 10 piece per million, but you stretch until 6 sigma, it become billion already, like one piece rose up out of 1 billion piece out of the production. Means the reliability also increases. Okay. Okay. Then there's another tool called Kaizen. Kaizen also important. At least you should hear it before. Kaizen is quality tools. The word Kaizen itself is a continuous improvement. It's a Japanese word called continuous improvement. TQM, you have all these components. You can read. This is a PDCA, deeming PDCA cycle. What is P? Planning, plan. D is do. This is a PDCA cycle. Planning, do, study, or what is it? Forget already. Access or something. Okay. Okay. Then this is the Six Sigma. Six Sigma actually it takes the philosophy of karate or taekwondo. So because this system is from the Japan, so what they do is that this Six Sigma actually have a program. You have a level 1, level 2, level 3, level 4. They group you based on the belt color. So you're the white belt, you're the green belt, you're the black belt, and so on. Black belt means you are the masters. You are the lead projects. You are the project leader. Okay. So this one you go and see lah. This is all this. Okay, we go into the Six Sigma goal. Okay, so this is the diagram that I draw on the whiteboard just now. So this, what I mean by Six Sigma? Six Sigma is a statistical methods to identify or minimize the defect. The final goal of Six Sigma is to near zero defect in the process. So if you look at this diagram, so you know that this is a center distribution of your normal distribution graph, or yeah. So this is a center point. Then from center point, you have 1 sigma, 2 sigma, 3 sigma, 4 sigma, and so on. Left hand side is negative, right hand side is positive. Okay. Then you will set your lower standard limit upper centimeter. Later, we will further study on the detailed calculation, maybe tomorrow. But today, just introduce that, okay, you have a certain tools. What mean by all this? So later, when we do analysis, maybe I will no longer pull this graph out again. So it means if we mention Six Sigma, means we need to deal with 1, 2, 3, 4, 6 until 6. Okay, then you find the probability of the defect. Okay. 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 So then there is a one acronym, DPMO. DPMO is this is Six Sigma, near defect possible. Is there's I think this one is the old one. Numerical goal of Six Sigma, they want to achieve 3.4 defect per million opportunities. DPMO is defect per million opportunities. I mean, out of 1 million piece, maybe 3 to 4 pieces is defect. DPMO. Okay, so there are 4 basic steps in Six Sigma, which is align, mobilize, accelerate, and govern. But I don't go deep into this, but at least you know Six Sigma have 4 steps. You align, you mobilize, you accelerate, and govern. Then you have 4 levels of Six Sigma: white belt, yellow belt, green belt, black belt. So each one have their own strength and duties to do. If you have a white belt, what you do, what black belt, what you do. Okay. So there are 4 steps in Six Sigma: align, mobilize, accelerate, and governance. The first, align. Align is to group all the members together and then align. Okay, tell what is our goal today. Sigma projects, you align everyone in the same page. What is the goal? What is the problem you need to identify, and so on. Mobilize, you start to pick your team member already. Okay, start to pick your team member. And this one, normally, when you mobilize, you will lead by someone holding the black belt Six Sigma certificate. Okay. So this is the Six Sigma process. So you go and see there is a process from define, measure, analysis, improve, control. So each one have their own process. Okay. So I'll let you know if this diagram come up for your final, but at least you know there is a process inside the Six Sigma. Okay. Accelerate means you continue to improve, you give trainings. Then the govern, continue monitoring. Acronym DMAIC, define, measure, analysis, improve, and control. Just now I show you the big graph just now, this one. Right, so each step have their own steps, what tools they use and so on. Okay. Okay, this one you read. Now, design for Six Sigma, also another textbook wording. Design for Six Sigma, DFSS, is a systematic approach to achieve Six Sigma goal, which is near zero defect. Okay, so there's a few steps also, right? Then another word, if you go to outside world, like you work as a production floor managers. Six Sigma, we understand, but if the Six Sigma plus a word in front called Lean Six Sigma, Lean Six Sigma actually combine the word lean. What I mean by lean? You cut down all the fat. You want to have lean body, right? You cut out all the fat. So in this case, in manufacturing, it's called you reducing all the waste inside the process. Means the material, maybe the material is very expensive. For example, you're manufacturing a titanium or you're manufacturing a gold piece of jewelry and so on. So every single drop of the gold is very expensive. So you don't want to waste the gold. So this is you lean the process. Lean the process means you reduce waste, plus you use the approach in Six Sigma. You combine these two, you get Lean Six Sigma. Yeah, this is the overall philosophy. Okay. Okay. This is how house of quality. But I don't go deep into here. I'm not sure whether I should teach you this one, but at least when you do you have capstone design? No. You have EDP. EDP is what? Engineering design project. You should heard about house of quality in EDP. No, okay. Okay. Never mind. House of quality is in the when especially it's important when you do in the R&D department. House quality is you identify customer requirement and then you do some analysis. Okay. Okay. So there are some tools. One is house of quality, quality function deployment, cause and effect matrix. Just now I show you already. FMEA, failure mode effect analysis. This one also you should learn in your EDP. But I'm not sure whether you know about this one. But there's a process to do FMEA. Okay, FMEA analysis is important if you work in the engineering R&D department. Okay. T-test is a sample of tests that you need to take. How many sample in the production, in the quality? You want to measure the quality, how many sample that you need to pick. So it's called T-test. Again, I don't cover this one in this module because too many things to learn already. So I don't cover this one. Right? There's a specific chapter to do sample tests. 1 sample, 2 sample, 3 sample tests, and so on. Statistical control, this one will be the main focus of this chapter. So we will do calculation maybe tomorrow. Lots of calculation. Design of experiment, this one also very important. If you know Prof. Izzat, he like to ask question about this one. Okay. Okay, so tomorrow class, we will look at the statistical process control. Okay, so we end our class a bit early today. Okay. Hey, sorry, not tomorrow, Friday. Okay, sign your attendance. Sign attendance.